So yeah, hello, I am already Anirudh Reddy. So I am here today in this video to give presentation in the for the topic of multiple linear regression. And I have chosen the dataset of, okay, I'll go with the first slide. So I have chosen the dataset, the red wine dataset for the multiple regression. Uh, so in this PPT, I'll explain about multiple linear regression in context of wine analysis and explain the understanding how wine properties affect the crucial for the wine industry. And we'll talk through the real world examples of multiple linear regression in wine analysis. So yeah, we'll go with what is multiple linear regression. Multiple linear regression is nothing but it is a statistical method used to model the relationship between a dependent variable and multiple independent variable. So how does it help? It helps us to understand how the independent variable collectively impact the dependent variable. Uh, this is all about multiple linear regression. And so yeah, we'll go with the equation. The basic equation of multiple linear regression is y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus and so on up to beta k, like it's an nth term, plus e represents an error term. So in this equation, the y is a dependent variable and the beta naught is an intercept and beta 1 x1 is an explanatory variables. So yeah, in this project, in this PPT, I'll explain in the systematic manner of which pipeline I have used, and in this project involves the data sourcing, explanation, and model creation, evaluation, and interception. So yeah, I have used an R code. I have used R code script for this project. We can use R code or Python, but I have used an R code, which is better for me. I would like to prefer R code when compared to Python. And this is the R code you can see over here. You can see also. So yeah, this is the data set, which has multiple terms in the red wine: fixed acidity, violation acidity, citric acid, residue, sugar, chlorides, and sulfur oxide, sulfur dioxide density. So yeah, in this we need to pick a dependent variable for a regression analysis and a variable whose values will be predicted. And the quality seems to be as good as candidate as any. Let's check out one of the quickest and most informative ways to understand the variable is to make the histogram. It gives the data ideal of the both center and the spread of its values. So this is the graph. This is the graph depending on the values of fixed acidity and everything. So yeah, now we have plotted the density against the fixed acidity by using the R code. So yeah, here you can see a positive correlation and a quite stepped one. There are some outliners, but as the whole, there will be a step looking line that like out of the drawn. So you can see the dots over here. So the values over here represent the density, and the values over here 6, 8, 10, 12, 14, and 16 represents the fixed acidity. So yeah, I have started code with these by creating a model by making a variable called R model, and it is used as linear model regression approximately. So yeah, I have plotted predictions against the actual results. Like this is predicted acidity and this is an actual acidity. You can see the difference over here and here. You can see the lot of dots over here. Like there are minimal values, and I have made here like a bit longer. So there are like point values over there, and over here I have used 6, 8, 10, 12, and 14. So this is an predictions against the actual results. The actual results one is this one which we have used previously, and here you go. Here, so yeah. Next, making the linear regression model our second model, ordinary least squares. So this is the code which we have used previously, and we have evaluated model with the summary. So you can see the red line graph. So this is a linear regression model. This is the second model actually. The first one is this one, and this is the second one. So these are the variables. These are the results. OLS results. You can see the variable fixed acidity and the density and omnibus and the probe and the skew and curves over here. And next, this is our third model of linear regression. So multiple linear regression. So yeah, we have got a much closer batch between our data and our predictions. We can see that the shape of the data points is much similar to the red line. So you can see, you can observe over here, the data points over here is like widely spreaded, and in our third model, they're along with the red line. You can find the difference. So this is a third model. Uh, yeah. And this one is model evaluation. We can check the another metric as well, the RSME. RSME stands for root mean squared error. This is a measure of accuracy of a regression model. The very simple put, it's formed by the finding average difference between the predictions and the actual values, which we have used in the third model, second model, and the first model. The predictions graphs which I have showed to you, and the RSME, the root mean squared error, tells us how far and average predictions were be mistaken. And RSME of 0 would mean we were making perfect predictions, zero point 0.6 significances. We are on average about zero point 0.6 of unit fixed acidity away from the correct answers. Uh, that's not bad at all. Yeah. And this is the code which you can see here, define a function to check the RSME, remember. So yeah, this is a code and we got the value. And here are the results which we got. Here are the results. We got the interception of results. The data model explains the approximately of 91.8% of variance in the fixed acidity dataset as indicated by the K, but by the R squared value. Most of the explanatory variables are statistically significant in explaining fixed acidity with p-values than 0.05 expected for the sugar, sulfur dioxide, and alcohol. So here, the negative coefficient of chloride suggests that the chloride levels increases, fixed acidity tends to decrease. Then density has strong positive influence on the fixed acidity. So this is the results. Uh, the approximately 91.8% of variance is fixed acidity in the dataset. And next we come to model sustainability. The model shows that good overall fitness as indicated by the statistic and its associated p-value. P is less than 0.05. The omnibus and Jarque tests suggest that residential are not normally distributed, which might be warrant further investigation. Implications. These results suggest that we can use the model to predict the fixed acidity based on the selected primary variables, the significant factors. Example like chloride density provide insight into how the specific wine properties affect the acidity. So yeah, while we'll coming to conclusion, like here we have concluded the multiple linear regression analysis successfully predicted the fixed acidity of a red wine. And again, I'm mentioning I have used the red wine data set. So in this multiple regression, it has successfully predicted the acidity of the red wine with a R squared value of 0.981, indicating strong relationship between the selected wine property and the fixed acidity. The significant variables such as chloride and a density provider actionable in the insights of winemakers to optimize the wine production. And further refinement and explanation address referential distributions and the interaction between the variables. We can enhance the model's accuracy in this project. This project underscores the value of data analysis in improving the wine quality and informs the future research in the wine analysis and production. So this is all about this project. So thank you. So this is all about the presentation about multiple linear regression by using the data set of red wine.